Good afternoon, Algebra 2. Today I'm going over the notes from Monday. This is day 6, and we're working with exponential functions and equations. So to review, example 1, we have x squared times x to the third power. When you do these types of problems, you have to remember that if you have the same base with different exponents, there are various rules you'll need to follow. In this case, we have the same base of x. We're going to follow what's called the product rule, which means we're going to add the exponents. So x to the squared plus x to the third gives us a result of x to the fifth. This is a plain example of the product rule. Example 2, same exact thing again. Here I have the same base, x to the 4/5 times x to the 6/5. My base value is x. What I'm going to do is add my exponents, 4/5 plus 6/5. Since they have the same common denominator, I can add the numerators, and I get 10 over 5. When I simplify 10 over 5, I get 2, so I get x squared for my final result. This is all review of Algebra 1, second semester. Example 3, we have the same type of problem again. This time, though, I have different exponents with different denominators. My base y is still the same, so I'm going to go ahead and take 2/3 and 3/8, and I'm going to find a common denominator for them, which will be 24. 24 is common to 3, 24 is common to 8. 8 times 3 is 24, so 3 times 3 is 9. 3 times 8, is 24, there we go. And 8 times 2 is 16. So what I have is 16 24ths plus 9 24ths for my exponent. When I simplify it, I get y to the 25 24ths. However, you cannot have an improper exponent. So let's go ahead and take 25 over 24, the fraction, and let's make it improper. Actually, make it a mixed fraction. 24 goes to 25 one whole time, with 1 left over out of 24. This is how we're going to determine our final answer. This whole number 1 means I have y to the first power. The 1/24th means I'm going to have another y being multiplied to the 1/24th power. So this is a special case that you're going to want to make a mark on your notes whenever you're dealing with an improper fraction or an exponent. Example 4 is a review of the quotient rule for exponents. When you have the same base in the numerator and denominator, you keep your same base, like in this case of x, and you subtract the top exponent minus the bottom exponent. 9 minus 6 will give us a result of 3. So we get x to the third power. For example number 5, we begin first by simplifying our coefficients. 9 divided by 3 is the whole number 3. Now I'll deal with my x's. I have the same base on the top and bottom of x, and I will apply the quotient rule, which says to subtract the exponents from the top and the bottom. So I have 3x to the third. For example 6, what we're going to do here is we're going to practice the quotient rule. We have x's that start off our expression here, x4 over x. That means I'm going to have x to the 4th minus the 1 that I had from the bottom, which gives me x to the third power. If I deal with the y's now, in the same exact way, I have a base of y, a 5 on the top exponent, a 2 on the bottom exponent, that gives me y to the third power. These are both positive answers, so really all I end up with is x cubed times y cubed. And there's my final answer. For number 7, this is a review of the zero exponent rule. Any number, term, or expression to the 0 power is always going to be 1. 9 to the 0 is 1, x to the 0 is 1, 25x cubed y squared to the 0 power is 1. Anything to the 0 power is always going to be just a 1. And now for the back of our notes, we're going to practice the product of a power rule. When you have exponents inside parentheses and outside, the rule is to keep your same base and multiply the inner exponent times the outer exponent. 2 times 3 is x to the 6th power. Same thing works even if it's a fraction. I have a base of x, I'll multiply 4 times 5, which is 20. I have this denominator left over of 2. I'll simplify that exponent. 20 over 2 is 10. So I have x to the 10th power. Moving on to number 10. We have the cube root of 8x to the 6th power. What I'm going to do is split this up as the cube root of 8 times the cube root of x to the 6th power. Cube root of 8 is a number times itself again, which will give us 8. In that case, we have 2. The cube root of 8 is 2. Now for the second part of my problem here. I'm going to go ahead and rewrite this as an exponent. So I have x with the inside exponent of 6 with an outside root of 3. I simplify x to the 6/3. 6 divided by 3 is 2. So my final answer is the 2 coefficient I had in the beginning with x squared attached to the end. Pretty basic, pretty easy. It's all review. For number 11, we have multiple terms all being multiplied. So the first thing you do is you multiply your coefficients. 2 times 3 is 6, times 4 is 24. So there's the first part of our answer. Now we have x squared, which will then be added to the 1/2 exponent, which will then be subtracted by 3. All these exponents will be added together. When you do that, 2 plus 1/2 minus 3 equals x to the negative 1/2. We know that a negative exponent places it in the denominator. You keep the same fraction, but it's positive now. Let's go ahead and change this denominator to a radical and get 1 over the square root of x. So we place everything together. 24 was our original beginning answer, times this fraction answer we got, the square root of x. Multiply everything across the top, you get 24. Multiply everything across the bottom, you get the square root of x. You can't go any further, so there's our final answer. And for our final example, number 12, here we have the product of a power rule. Excuse me. The rule is take every inner exponent and multiply it times the outer exponent. So I'm going to take all these terms and multiply the exponent that represents them by 6. So I have x times 1/3 times 6 times y to the negative third times 6 over y to the first times 6 times x to the negative 2/3 times 6. I clean everything up. X 1/3 times 6 is 6/3, which simplifies to 2. Y is going to be negative 3 times 6, which is negative 18. On the bottom, I have y to the 1 times 6, which is 6. And I have x, negative 2/3 times 6 is negative 12 divided by 3, which would be negative 4. Now I'll apply the quotient rule. I'm going to have x with the top exponent of 2 minus the bottom exponent of negative 4. I have y's with the top exponent of negative 18 minus the bottom exponent of negative 4. When I simplify these two things, I get x to the 6th on top, I get y to the negative 22nd, it looks like, on the bottom. Because it's negative, it will be my denominator. So my final answer will be the positive x to the 6th on top with y to the 22nd power. I feel like I did something wrong there. Let's see, no, that's right. Negative 18 minus negative 4. Actually, it should be like that. Should be, I think, positive 14. There we go. Either way, you get your x stuff on top, y on the bottom. Those are your basic notes for day 6, I believe. Yeah, if you have any questions, feel free to ask me. Other than that, best of luck on your assignment.